Alright guys, here's my video explanation to help you with on your homework tonight. You got homework 3 and 4, front and back of this worksheet. So the first page, homework 3, is just dividing monomials. So in here, we're going to use the quotient rule. Ew, that's bad. Let me fix my font. Sorry about that. And that rule tells us that whenever we have like bases, let's say we have x to some exponent of and x to another exponent. Like bases means we both have x here. Let me get my pencil. This doesn't look great. Whenever we have like bases, we just subtract the exponents. I ran out of room, so I'm going to move this over. Sorry about this. So this would be really x a minus b, okay? And if we have numbers, coefficients, so like if we have, for example, let's say we have a 5 here in front of this, and then we had a 2 here, we just divide them like normal. So this would end up, well, that can't be divided. Let's make this 15 and make this a 3. So then this will make this a 5 in front of here. So I'm going to talk about that. This is what we did on the guided practice. So kind of refer to your guided practice that we did to help you. So if I do like number 1 here, like base is the y. So really you keep that like base and you just subtract. And I know you can do this mentally. And then there is our simplified answer. All right. If they're the same, remember you can cancel them. And this just turns into 1. Now, if you have 2 variables, like we do on number 3, you do one at a time. So x to the 4th minus, or divide by x to the 3rd, we subtract. That's just going to give you an x. And then we go to the y's, and that would give me a power of 3. So we're just subtracting like bases and then simplifying the answer. So if we do have a variable, like for example on number 5 here, that's kind of what I was doing before. The coefficients can be reduced. That can be simplified to just 5. And then here we're subtracting the like bases. So this is a, remember that's an invisible 1, so that would just be 5a squared, and that's our final answer. Now, if we have a fraction, let's say we can't reduce it to a whole number, like on number 7 here. Or not number 7, which one I was going to talk about? Number 10. That's the one. Here, we would have to reduce this fraction. So they have 3 in common, and when I reduce that, you would get the fraction 7/9. Now I'm just simplifying each like base. So my m is now to the 3rd power, and my n is just an n, because 5 minus 4 is 1, and I don't need to, that would be 1, but we don't have to put the 1 because 1 is invisible, so we just have this n. So basically the final answer is 7/9 m to the 3rd n. That is our simplified answer. All right. If you don't have a like base, like on number 9 here, one of the things, there's an a, but there's not a b. I mean, there's a b, excuse me, but not an a. So you keep the a. So this would be a -4a, but then the b's you can simplify to just 1b. So just b. All right. Now, when you get to this bottom half here, this is when we're going to have some multi-steps. Let me just go over this real quick. Hold on just a second. Okay, so sorry about that. For the complex problems here, this next section, you have more than one rule shown here. Like on I'm going to go number 13, for example. Because I see this parentheses here, and I have the exponent 2 outside the parentheses, I have to do the power rule first. So this is this -2 squared, and then m now to the power of 8. Now that's all over 8m squared. Okay, and we need to basically simplify our coefficients first. So this is going to turn into 4m to the 8th power over 8m to the 2nd power. And now we're back to doing the problems in the previous section. So we're just going to simplify the coefficients. That can be reduced to 1/2. Subtract your exponents. So this is m to the 6th. So if you see parentheses, you're going to have to do that first. So like on 15, I'm going to just jump to 15 to kind of get you started on this. You need to distribute that 5 to each term. That would be 3 to the 5th power. Now x to the 25th power, y to the 15th power. And I have to do the same thing for the bottom. This would be 6 squared, x to the 20th power, y to the 14th power. And now we just need to simplify our coefficients. So 3 to the 5th power is 243. Okay, everything else is going to remain. And then 6 squared, that's just 36. And now we're back to using the quotient rule, which tells us to subtract the exponents. So, and then see if you can simplify what you can. This can be reduced. So try to reduce the fraction here and then subtract your exponents. Now if the parentheses is with a fraction, all right? So like I'm gonna jump to number 17 here. This parentheses, and then we have the exponent 3 outside the parentheses. We have to distribute the exponent 3 to the top and to the bottom. So look, this looks like this: 2 to the 3rd, y to the 15th, over 3 to the 3rd, y to the 6th. We're going to simplify the coefficients. So 2 to the 3rd is just 8, and 3 to the 3rd is 27. So I keep, and now I'm just simplifying the fraction, which I can't reduce that anymore, but I can subtract like bases here. So we just keep the 8 over 27, and then we have y to the 9th power, because 15 minus 6 is 9. And then that's our. So you need to distribute to each term to the top and bottom. I'm kind of trying to draw an arrow to the top and bottom. And then this last section, you're going to have to do the multiplication, like simplify the fraction first, and then do your addition. You got to follow order of operations. So this requires me to do the top first, the multiplication. Doing the product rule, this is going to give me 12a to the 9th b squared, and that's going to now be over the 6a to the 7th b squared. Now I want to simplify that because that's now going to be added to our 16a squared. So we just need to simplify this here, which we can. That gives me 2a squared, and then our b's cancel. And now I'm adding that to 16a squared. And now we have our answer, because we just combine those like. All right, and now for 20, make sure you do your power rule first. So actually, this should be 2 squared, x to the 6, okay? And that's going to get multiplied to 3 to the 3rd, y 12. So simplify your coefficients, multiply, that still stays over 12x, y to the 5th. So then we can do the multiplication, then do your quotient, subtract, and then do your subtraction at the very end. And I wrote this wrong, this should be 7. So in order to subtract, when you simplify, you should end up with this like term, okay? Now, on the back here, now we're trying to simplify so that the answer should contain only positive exponents. So whenever we have a negative exponent, we have to flip it and change it to a positive. So that's all we're doing here. But we're only doing it to the one that is negative, to the variable or term that is negative. So let me just, I'm changing my font here. So on this problem here, only the y has the negative exponent. So only that is over 1. And when I flip it, only this term, and I probably should flip it down here, would have the 1 over y to the third. So the y to the third has to go to the bottom of the fraction. Everything else that's positive, 5x squared, stays on the top of the fraction. And that is our simplified answer. Okay, so here we have 2 terms that we need to flip. Okay, try that. Now, on this row, now we're doing the power rule, so we're distributing the negatives. So do the power rule first. Like this would be a to the negative 4, b to the negative 8. Now, these are both negatives, so we need to flip. So this is 1 over a to the positive 4, b to the positive 8. Okay, so do your power rule first, and then any other operations after that. Like if I do, because sometimes when you multiply a negative times a negative, it's going to turn into a positive. So like on number 5, this would be negative 8. And then I'm multiplying that to x to the positive 15, y now to negative 20. So now this term, the y, is the one I need to do the reciprocal. I need to flip to make it a positive. Okay. So do your power rule first, and then change your negative exponents to a positive. Okay. Here we're doing our product rule because this is showing multiplication, and that means like base, you add your exponents. So negative 5, and now we have to change that to a positive. Okay. Then this is when we're going to have some complex. So we're going to do like the power rules first. So this is x to the negative 9. And then this would be times the negative 2 to the 4th and y to the 20th. And now we're just getting rid of, we're not getting rid of, but we're changing our negative exponent to a positive. So this is what we need to flip. Okay. Remember, when it's positive, it stays, if it's positive, it stays on the top of the fraction, because this x to the 9th goes to the bottom. So this negative 2 to the 4th power actually turns into 16, and this is y to the 20th. So use your power rules first, and then do your flipping, okay? Now, this last section, it's the same thing. Your product rule and your quotient rule is the same, even though we have decimals, even though we have scientific notation. So this is like a coefficient, 7.2, and the 1.4 are your coefficients. We're multiplying like bases of a base 10. So the coefficients get multiplied together. Oops, I can't write that right. That's a 4, sorry. Then we're keeping the base 10, and here, whenever you multiply, we add the exponent. Okay, so this we just have to multiply the decimals. So on this problem, this will come out to be, when I multiply this decimal together, this is 8.6, and we're going to just keep times 10 to the 7th power. Okay, so do the same thing. Multiply coefficients, add your like basis, add the exponents. Now for the division here, now we're dividing the coefficients. So the coefficient here is a 3.9 and a 2, so we're dividing that. All right, and we're subtracting, so times like basis. Whenever we divide, we subtract. So basically this is 3 minus 3, which is 0. So this is going to cancel, leaving me just this number. On a problem like this, see, this is already in like kind of quotient format. We're going to divide the numbers, subtract here. Now, the beauty about scientific notation is when we subtract it, we get a negative exponent, we can keep it a negative exponent. So in a problem like this here, when I divide 1.5 from 5.6, that's going to come out to be 0.25. Now I'm doing times 10, keep the base. If I do 1 minus 4, that's going to give me a negative 3. Okay. Now, the only thing I would do here now is, in scientific notation, the coefficient, this number has to be a number like between 1 and 9. It can't be a decimal. So we just have to remember to move this decimal over. And I think we'll talk about a little acronym to help you remember this, but if I move this over to the right, this becomes 2.5. And so and now this exponent, since I'm adding basically a decimal place, this is going to be to the -4. All right. So hopefully this will help you to get through this. Be ready to come in, ask questions, and do some problems on this tomorrow. Thanks.